Welcome to lesson 3.3, graphing quadratic functions. In this vertex form. Okay, so in vertex form, and we've talked about this in class, it's f of x is equal to a times the quantity of x minus h squared plus k, where h comma k is your vertex. Okay, if a is greater than 0, which is positive, then you know that your parabola opens up. If a is less than 0 or negative, then it's going to open down. And you can see if your parabola opens up, then you're going to have a minimum point at your vertex. And if your parabola opens down, with a being negative, then you'll have a maximum point at your vertex. And then knowing that each of these parabolas are symmetric, we can basically cut them almost exactly in half with this imaginary line. We call this the axis of symmetry. And it will always be an equation, x equals h, which of course is the x value of your vertex. Okay, so let's go on. In our vertex form, f of x equals a times x minus h, quantity squared plus k. H represents horizontal movement or translation. Whether you're moving left or right from the basic quadratic. And K represents vertical translation. Of course, moving up or down from your basic quadratic. Okay, so let's talk about the range. If we have a quadratic that opens up, remember, this is the case that a is positive, greater than 0, then of course we'll have a minimum. And right here is our vertex, which would be the point h comma k. So our range then, remember, range refers to the values of y. Our range would start at this value of y, which is k, and it's included, so it would be a bracket k, comma, and it would go all the way up to positive infinity. And again, that would be a parenthesis. If a is negative and we have a quadratic that opens down, this was a being less than 0, then our vertex here is actually a maximum. And so this point, again, is h comma k. So the range for this one then the lowest value of y would be negative infinity, comma, and it would go all the way up to this maximum point that has a value of k. And again, that would be included. Okay, so let's try a real example. Say we had f of x is equal to, let's see, 5 times the quantity of x plus 4 squared plus 3. So what we need to know is a, of course that's 5. Right away it's positive, so you can say, oh, I know it's going to open up, and I'm going to have a minimum value. H, in this case, H has to be -4. And why is that -4? Well, remember the form is, let's get the right pen, it's A times X minus H, quantity squared, plus K. In order to have plus 4, that would have to be A times X minus -4, quantity squared, plus K. So we know H is -4, and then K, of course, is 3. So what does this look like? Well, since A is positive, we can just quickly draw. And we know it opens up. Our vertex here is a minimum, and of course that's the point H comma K, which is going to be -4, comma 3. So there's our vertex, but it's also a minimum point. So then what does that make the range? Well, remember, range is the value that y takes. So the lowest value of y is right here, 3 of our vertex, and it's included, comma, and it continues up forever. So then the upper boundary is going to be infinity, and of course that's a parenthesis. And now we want to know, when does this increase? On what interval is this graph increasing? Well, it's increasing from the vertex in this direction. So remember, when we talk about increasing or decreasing, we're talking about as we move along the x-axis. So it's increasing from this x value at the vertex. But remember, that's a turning point, so it's never included. It's always with parentheses. So it's increasing on the interval from -4 all the way to positive infinity. Well then, when is it decreasing? Well, it would be decreasing on the interval, if we look, on this part of the graph. So from -infinity, remember, as we move across the x, so it's decreasing from -infinity all the way to -4. And again, parenthesis, because this is a turning point. It can't be increasing and decreasing at the same point.